Let's do a very similar calculation to the one we did in the last video, except this time, instead of giving you mole amounts for the reactants, let's suppose we're given grams. Let's use the same recipe that we were working with last time, the recipe for industrial production of ammonia. All right, suppose we have, 5 grams of N2 and 4 grams of H2. And we want to know how many grams of NH3 are going to be produced. Now, this kind of problem has a name. When you want to predict a gram amount of product, the gram amount of product, grams of product predicted is called theoretical yield. So there's some vocabulary for you. If they're asking you to do a problem like this, they might say, you have 5 grams of N2 and 4 grams of H2. What's the theoretical yield in this reaction? And when they say theoretical yield, translate that into grams of product. And the product here is ammonia. Okay, so let's do it. The first thing that we have to do is predict grams of ammonia for each reactant. All right, now last time was pretty easy because we were doing the calculations in moles. Why can't we keep things easy? We can. Why don't we just turn all these gram amounts into moles and then just work in moles and do pretty much the same thing that we did in the last video. So I'm going to take my 5 grams of N2 and turn it into moles of N2. Now, the molar mass of N2 is something like 28 point. I can figure that out. So if I pick up my calculator and I take 5 divided by 28.01, I'm going to get something like 0.78 moles of N2, something like that. All right, now what if I do the same thing for the H2? We can convert grams into moles using the molar mass of the H2. And that's going to be something like 2.016, because one H is 1.008, so twice that is 2.016. So I'd have 4 divided by 2, that's going to be about 2, right? It's going to be a little bit less than 2. It's going to be something like that. Now I have molar amounts for each of my ingredients, and I can just do it the same way that I did in the last video. I'm going to predict, how about we just predict moles of NH3 for each one, and then we can turn it into grams later if we want to. And this will save us a little work because we only have to change the moles of NH3, that is the lesser amount, instead of doing both of them. So for each of these, I'm going to figure out how many moles of NH3 I've got. Now I look up at my equation here, and I want to turn moles of N2 into moles of NH3 here. What should I put here? I look up at the equation, there's a 1. And what should I put here? I look up at the equation, there's a 2. So it's going to be it's going to be twice this. So what's that? That's something like 0.357, something like that. Okay? And now let's do the same thing for the hydrogen. Take the 1.98 moles of hydrogen and let's convert it into ammonia. I know moles of H2 has to go on the bottom and moles of NH3 has to go on the top. So I'm converting both of these things into ammonia. Let's see, I've got a 3 sitting in front of the H2 and I've got a 2 sitting in front of the NH3. So that's going to be 2/3 of 1.98. That's like 1.32 something. Whoops. NH3. Okay, so which one's the lesser amount? This one. This is the amount of NH3 that I'm actually going to get. That's the theoretical yield. In moles, what we have to do is change that into grams now to get the theoretical yield that we wanted originally. Now, there's a lot of steps here, right? They're all simple steps, though. Keep in mind what the overall goal of this is going to be. We're trying to get that. I guess to turn this into grams, I am going to need a molar mass. So nitrogen is like 14.00 something, and then hydrogens are 1.008. 3 times that is like, I don't know, 3.03 plus 14 is something like 17.03 grams of NH3. Okay, and now I'm going to add, or I'm going to multiply this amount of moles times the 17.03. That's going to cancel out the moles, and that's going to give me the gram amount. It'll be something like 6. It'll be like 6.08. That's the amount of NH3 that I'm actually going to get. This is the theoretical yield. This is what I was trying to get up here. So now look at the steps that we used to get this. We took all the gram amounts that they threw at us and turned them into moles. That was the first thing we did. The next thing we did was take all the mole amounts that we got there and turn them into moles of product. And see which one gives us the less moles of product. Okay, and then I turn moles of product into grams of product, and I have predicted the theoretical yield. Now, what if I want to figure out how many grams of excess I'm going to have in this reaction? What's going to be used up? What is the limiting reactant? Now, you saw that this produced the smaller amount of product. So this is the limiting reactant. That means it's all used up. That means that there's going to be H2 left over. How much is going to be left over when we're all done with the reaction? All right, I'm going to take the amount of limiting reactant. And I'm going to use that to figure out how many moles of H2 were used up. Okay, so oh boy, I'm going to be up here. This is moles of N2 that I have down here because I want to cancel that out. And I'm going to put moles of H2 up here on top. So if I look back up at my equation, I have 1 mole of N2 for every 3 moles of H2. So it'll be 0.178 times 3. So that's going to be 0.535. So there's 0.535 moles of H2 used up. All right. So the initial amount of H2 that I had was 1.98. Minus 0.535 moles of H2 used up is going to give me what, 1.44, something like that, 1.45 I think, 1.4, yeah, okay, 1.45. So that's how much H2 is going to be left over. Now if I want the gram amount that's left over, I can turn that into a gram amount. 1.45 moles of H2 turned into grams what did we say it was? 2.02, right? 2.016 is 1 mole. So I take that 1.45 and I multiply it times 2.02. I'm going to get something like 2.9. What am I going to get? 2 grams of H2. All right, so this is left over. So now we're done with this long calculation. Now what we had before was 5 grams of N2 and 4 grams of H2. So before anything happened, we had 9 grams of stuff. Now, we ought to have the same number of grams of stuff after. If you add the grams of product that you predicted, plus the grams of leftover stuff that you predicted, that all add up to the initial mass. The initial mass was 9 grams. So if I got all this right, this plus this ought to add up to 9. So that's a good check on this. Everything that's the total mass after the reaction, this plus this, has to be equal to the total mass before the reaction. And then you can be sure that you got all this right. Now this is probably one of the toughest calculations that we've done all semester. Not because it's hard to do, but because there's so many little steps. So keep straight all of the little steps here, and the best way to do this is to try as many of these as you can yourself.